Hello my beautiful people, you're welcome again to my YouTube channel Mathematics Made Easy. Alright, so in today's video we'll be solving this beautiful question. This is another episode of the complete elliptic integral of the first kind. The question says find the value of k of 1 over square root of 2, that is the elliptic integral of the first kind of 1 over square root of 2. We want to find it. Okay guys, so before we start solving this problem, if you are new in this channel, please don't forget to subscribe to our channel, like our videos, share, comment, and then also click the notification button so that whenever we drop video, you'll be the first to watch that video. All right guys, so now let's dive into the solution on how to find the close form of the k of 1 over square root of 2. If you can still remember what I taught you in our last class, and then if you haven't watched it, I'm going to send you see the link in the description. All right, here's the question. Here is the integral representation of the complete elliptic integral of the first kind. So we have k of k. This is equal to the integral of 0 to pi over 2, then of the theta, then of the square root of 1 minus k raised to the power of 2 sine raised to the power of 2 theta. All right, so then we want to find k of 1 over square root of 2, so that will be k, then of 1 over square root of 2, then that will be equal to the integral from 0 to pi over 2, the theta, then over square root of 1 minus 1 over square root of 2 raised to the power of 2 sine raised to the power of 2 of theta. Now we're going to have k of 1 over square root of 2, then this will be equal to integral from 0 to pi over 2, then of the theta, then over the square root of 1 minus 1 over 2 sine raised to the power of 2 theta. Wow, this is beautiful guys. So let's solve this integral. This is a beautiful integral. So now let's make our substitution. So we can say let u be equal to sine theta. So if u equals sine theta, then we're going to have the u equals cos theta, the theta. Then you make the theta the subject of the formula. Then we have the theta is equal to the u over cos theta. Then if you write cos theta in terms of u, so that will be the u, then over the square root of 1 minus u raised to the power of 2. So let's move on, and then you check the limit is going to change when u is pi over 2. When theta is pi over 2, you're going to have u equal to sine pi over 2, and sine pi over 2 is 1. Then when theta is 0, you have sine 0. Sine 0 is 0. So when theta is pi over 2, u will be 1. When theta is 0, u will be 0. Then we're going to have integral from 0 to 1. Then the theta, that will be the u, then over the square root of 1 minus u raised to the power of 2, then multiply by the square root of 1 minus 1 over 2 u raised to the power of 2. Then we can now write this integral as follows, that integral from 0 to 1, then of the u, then over the square root of 1 minus u raised to the power of 2, the square root of 2 minus u raised to the power of 2, and over the square root of 2. So then this will be equal to the square root of 2 multiplied by integral from 0 to 1 of the u, then over the square root of 1 minus u raised to the power of 2 multiplied by the square root of 2 minus u raised to the power of 2. Okay, so then let's move on. All right, so next page, don't forget this is where we have square root of 2 multiplied by integral from 0 to 1, then of the u over the square root of 1 minus u squared multiplied by the square root of 2 minus u squared. So let's make a substitution here. So making a substitution, so we can say let u raised to the power of 2 be equal to x. So if u raised to the power of 2 is equal to x, then 2u, the u is equal to the x. Then the u will be equal to the x over 2u. And don't forget, u will be square root of x. So that will be the x over 2 square root of x. So the limits still remain the same. Okay, so this will just be root 2 over 2, then multiply by integral from 0 to 1. Then instead of writing the u now, so that will be the x over square root of x here. So we are going to have the x, then over the square root of x, then multiply by the square root of 1 minus x, then multiply by the square root of 2 minus x. Okay, so don't forget that we can write 2 minus x as 1 plus 1 minus x. Okay, so then we are going to have the square root of 2 over 2 multiplied by integral from 0 to 1, then of the x, then over the square root of x multiplied by the square root of 1 minus x multiplied by the square root of 1 plus 1 minus x. Then you can also make a substitution here. You can say let 1 minus x be equal to u. Then if you do that, so x will also be equal to 1 minus u. Then we're going to have the x is equal to negative the u. So the limit is going to change, when u is 1, so that will be 1 minus 1. I mean, when x is 1, that will be 1 minus 1. So u will be 0. And when x is 0, u will be 1. Then we're going to have square root of 2 over 2 multiplied by integral, then from 1 to 0. From 1 to 0, then dx is now negative the u, then over x is now 1 minus u, that will be square root of 1 minus u multiplied by square root of u, then multiplied by 1 square root of 1 plus u. Okay guys, now because of this negative sign we can switch this limit, so this will be square root of 2 then over 2 multiplied by integral from 0 to 1, then of the u over the square root of u multiplied by the square root of 1 minus u multiplied by the square root of 1 plus u. Okay, so this is getting more interesting. According to the law of sorting, we have square root of a multiplied by square root of b. So this is the same thing as square root of a multiplied by b. Then square root of 1 minus u multiplied by square root of 1 plus u. So this will be equal to square root of 1 minus u multiplied by 1 plus u. And 1 minus u multiplied by 1 plus u. So this will give us square root of 1 minus u raised to the power of 2. So square root of 1 minus u multiplied by square root of 1 plus u. So this is going to give us square root of 1 minus u raised to the power of 2. So then the integral is going to become square root of 2 over 2, then multiplied by integral from 0 to 1, then of the u, then over square root of u multiplied by the square root of 1 minus u raised to the power of 2. So what we are going to do next, make another substitution. Let's see, we'll make a substitution. I'll make a substitution. The integral is so simple, but yeah, you understand. So now let's make another substitution. You say let u raised to the power of 2. Let's use t, okay? Then if u raised to the power of 2 is equal to t, then u will be equal to t raised to the power of 1 over 2. Then the u will be equal to 1 over 2 square root of t. All right. Then we are going to have square root of 2, then over 4 now. Then integral from 0 to 1. Then the u, so that will the t. So you forgot to put the t. That will be the t, then over the square root of t. Then square root of u. So that will be t raised to the power of 1 over 4. So that will be t raised to the power of 1 over 4, then multiply by the square root of 1 minus t. So square root of t multiplied by t raised to the power of 1 over 4, that will be t raised to the power of 3 over 4. Okay, so this will be square root of 2 over 4, then multiply by integral from 0 to 1, then of the t, then over t raised to the power of 3 over 4, then multiply by square root of 1 minus t. Okay guys, let's move to the next page. Yeah, next page. So this will be square root of 2, then over 4, then multiply by integral from 0 to 1 of t raised to the power of minus 3 over 4, then multiply by 1 minus t raised to the power of minus 1 over 2 dt according to the law of indices. That's what happened there. All right, so let's make quickly remind us the beta function. If you have beta function of m comma n, so this is equal to integral from 0 to 1 of x raised to the power of m minus 1, then multiply by 1 minus x raised to the power of n minus 1, then dx. So that's what's going to happen here also. So that will be square root of 2, then over 4, multiply by integral from 0 to 1, then of t raised to the power of minus 3 over 4 plus 1 minus 1, then multiply by 1 minus t raised to the power of minus 1 over 2 plus 1, then minus 1, then dt. Okay, so then we are going to have the square root of 2, then over 4 So multiply by integral from 0 to 1, then of t raised power. Now negative 3 over 4 plus 1. So that is going to give us 1 over 4. So that will be 1 over 4 multiplied by 1 minus t, then raised to the power of 1 over 4 minus 1. So that will be 1 over 2 minus 1 dt. Then you make use of our beta function. So then we are going to have the square root of 2 over 4 multiplied by the beta of 1 over 4, comma 1 over 2. So, and then we also know that beta of m, comma n is equal to gamma of m multiplied by gamma of n, then over gamma of m plus n. So then we are going to have square root of 2 over 4 multiplied by gamma of 1 over 4 multiplied by gamma of 1 over 2, then over gamma of 1 over 4 plus 1 over 2. So this will be equal to square root of 2 over 4 multiplied by gamma of 1 over 4 multiplied by, square root, gamma of 1 over 2 will be square root of pi. Then over square root of 1 over 4 plus 1 over 2. So that should give us 3 over 4. 3 over 4. Okay. Now, remember that gamma of 3 over 4 is equal to square root of 2, then multiply by pi, then over gamma of 1 over 4. Then we are going to have the square root of 2 over 4, then multiply by gamma of 1 over 4, multiply by the square root of pi, then divided by square root of 2, multiply by pi, then over. So this will be over gamma of 1 over 4. Okay, then this will be square root of 2 over 4, then multiply by ECC. So division will turn to multiplication. That will be gamma raised to the power of 2 over 4, then multiply by the square root of pi, then over, this will be pi root 2, or pi root 2. So root 2 will cancel out root 2 here. So this is what we are going to have. We are going to have 1 over 4, then into bracket gamma raised to the power of 2, 1 over 4, then multiply by, also we can say this is over square root of pi. Why? Now you know that 1 over square root of a, this is also equal to square root of a over a if you rationalize. So square root of pi over pi, so this is equal to what? 1 over square root of pi. Do you understand? So that is what happened here. So that's why I have 1 over square root of pi. So the answer is 1 over 4 multiplied by gamma square of 1 over 4 over square root of pi. So that's the answer to that question. All right, guys. So once again, please don't forget to subscribe to my channel, like my video, comment, share. God bless you. See you next time.